screen, you cannot do that. You cannot say, I'm going to draw a linear array. No. You have to fold it into an XY array. Okay? We will talk about that today. Okay? So there's one more thing we need to know. How the file is saved by color. Right now, there's only two colors. It's easy to confuse you. So now let's do this. I'm going to pick a color, red. Okay? I'm going to select the red. And I'm going to change one pixel to be a red, which is this one, or this one. So let's look at the second one here. The reason I didn't pick the first one is because I want to see the first one, the white, right next to it is the red. So we can tell when the red starts. Okay? And then when I do the file again, all right. So look at this one, the change. This is, we know based on our knowledge, this is not a black color, this is not a white color, this color is a red color. There's only 3 different colors in the file. So that means each FF combination is a color of RGB, right? But RGB to us, it reads RGB. But when you save, how does it say?
AGR.
We don't know yet, but we know definitely not RGB. It's something red. Okay? All right. So let's put it down. Let's put down the notes. RGB is same as, we know it is red here. So now we can find out the middle one. Okay? So very easy. What we go is go to the color. First, we close this file. We pick up your thing again. I'm going to change this to red, not to white, and then pick a green. The green is, this is green color. Which pictures we'll do this one again. Okay? And what's the change? This one. See that? The F used to be here, but right now it's here. So that's the green. So without doing the third experiment, we should find out this is how they say. Okay? This is how the file. So the file is saved upside down, and then the color is saved left to right. Because we're so used to RGB. But actually it is the opposite. Okay? I know. Make your life difficult. It's like RGB. No. Look on the other side. It is BGR. This is how it is saved. Okay? All right? Now, why is this important? It's because when you read in this whole bit of data as a linear array, you need to extract the information correctly. So the example I showed you, it reads 1 byte at a time. You can only read 1 byte at a time. Okay? And then once you read the byte, you look at its value. Look at its position and determine where you should save it. So when you try to do a letter like this, right, you get grid. Okay. The file is saved as this. This is your header. This is your pixel. Right? All right. So your job is reading it, everything in one. It's easy. The example showed you how to read everything. You specify this number of bytes I want to read, you read in everything. But you need to assign the pixels the right location. Okay? That's difficult. The reason is you need to know position 100 means x equal to 0, y equal to 0, for example. So your code has to be smart enough to tell by reading this location. This maps to that location, x, y. So when you display it, you display XY. Okay? That's the difficult part. The second difficult part is this image that you created is 24-bit color, but the display that we're using is how many bits? No, 8-bit. So we need to map this 24 bits into 8 bits conversion on the fly. So every time read in the stuff, we need to convert it, convert it. So assigning the position is not that difficult. The color is difficult. The reason is you read 1 byte, it is not your color. You need to read BGR all in together and then do the conversion. Okay? So how to do the color conversion? R, G, 8-bit each. Okay. First, the value that you can read from an SD card is always 8-bit. So to do the color conversion, you need to convert color by color. Understand? R, G, B, this one is 3, 3, 2. Okay? So how do you convert from 8 to 3, 8 to 3, 8 to 2? How do you do that?
Website.
No, you're doing a program. There's no website.